ourselves together and keep ourselves going on our own. We also encourage not only donations, but sponsorships. And if you want information about how to be a sponsor, please let me know. I'd be happy to let you in on that big secret. You also have some yellow pages on your table. Those are evaluation sheets. We ask that you fill those out. You can just leave them on the tables. There's no requirement for your name or other identifying information. We do use those and review them carefully. Thank you for that feedback that you'll be giving. After we finish with our lecture, we'll have a light lunch, and that will be put out in a little while. Now, introducing our topic today. As I said, the School of Christian Studies has the theme this year, of loving God's environmental creations in multiple events that will continue through April. In April, we have a field trip, so we'll have more information for that on that for you at a later time. In our spiritual tradition, there are 4 primary principles for why we are to take care of the environment. The first one is stewardship. It involves taking care of the resources that we've been given. The second principle is creation care. Earth is our beautiful home. It's been given to us. It's our responsibility to take care of it. The third principle is love your neighbor. Jesus taught the importance of loving one's neighbor as oneself, and loving this only Eden in the cosmos that we know of is part of our responsibility. And the fourth principle is justice and compassion. We advocate for environmental justice. If we view the world as God's gift to us, we will do our best to protect it and keep it going well. And now for our lecture. San Diego's water supply, conservation techniques, pure water technology, and regional challenges. Our speakers today, pardon me, first is Michael Bellori.
Hey, everyone.
Michael joined the City of San Diego Public Utility Department's Pure Water Branch as an associate engineer in October of 2023. He's a licensed civil engineer with over 10 years of experience in infrastructure planning, design, construction, and 7 years of that was while he was an employee of the City of San Diego. Prior to entering the workforce full-time, Michael earned his master's in water resources and environmental engineering. That sounds like an expert to me. Thank you, Michael. In his free time, Michael enjoys playing intramural basketball in a league, traveling and spending as much time as possible with his 2 dogs. Second person in our group is Roy Yu. Roy is a licensed professional civil engineer with 9 years of water and wastewater experience. You have wastewater experience. Oh, that's an interesting term. Okay, he is currently an associate engineer with the City of San Diego's Pure Water Division. In fact, he told me a little earlier he came to this project on purpose because this is what he wanted. Prior to joining the City of San Diego, Roy worked as an engineering consultant, primarily designing drinking water, treatment plants, and pump stations. Roy has an injured toe. He ran a marathon, and so he has a red badge of courage on his foot, right there. Now, I'd like to also introduce another person who's sitting in our audience, Marissa Cesari. Did I say it right? Caesar, okay. Marissa is a community, stand up, Marissa, say hi. Marissa is a community outreach liaison for the Pure Water San Diego project with over 5 years of experience in strategic communications. She supports Pure Water by coordinating program presentations, attending community outreach events around San Diego, and developing informational materials to share with the community. So, thank you all. Thank you for being here with us, and I'll let Michael get started.
Thank you. Thank you very much. That was a nice introduction. Yeah, I'm Michael Valori with the City of San Diego and Pure Water, and I'm just going to jump right into the presentation. Bear with me in case it's a little clunky. I'm not too familiar. I might ask Marissa for help with the technology, but okay. Thanks. Yeah.
That's you just hit on that side
all right.
of the thing. I think the space bar should work too.
All right. I just wanted to give her a good moment to shine. So yeah, thank you. All right, everyone. This here we start with this slide because it's one of the most important things we want everyone here to leave with thinking about. This idea of reusing water and having water that's been used by others, whether it's industry, municipalities, tribes on the reservations, we use it again. As you see here, we get water from north in the Colorado River and also in the San Francisco River Basin. I'm sorry, the Sacramento River Basin. These areas is where rain collects and drains all the way down to San Diego, all the way at the south, where that water drop is. Throughout that journey, both of these streams collect water from all those purple, yellow, and red spots. Those are all agencies and cities and villages and other people. So this idea of reusing water that was used for centuries and centuries and millennia is, time and time again, is not new. Here's a slide showing some of the things that we deal with here in San Diego and the Southwest in general deals with. The first is limited local imported supplies. As you see here, there's no lakes, there's no rivers, or maybe a couple, and most of the time they're shallow if dry. We also in this area, San Diego, Los Angeles, Phoenix, Las Vegas, immense population growth from all over parts of the country where people are moving. Bay Delta constraints. I won't confuse you guys with this. This is a little more scientific. Natural disaster risk. As you saw in the previous slide, there's basically two streams, two sources of water. If something was to occur along the way, we'd be in a lot of trouble only having two water sources. It'd be a lot better to have a local water supply so we're not dependent and not in such a risk position. And here's the big one. This is a very important one. Rising imported water costs. In 2000, we paid for a football field full of 1 foot of water, an acre foot, we paid $400. This year, we're paying $2,300, close to 6 times as much, and we have no control over this. This is set by upstream water retailers. Recurring drought, as many of you probably were living here up to 2019, 2020, there was about a 10-year drought or so, and that's when water costs started going higher, hand in hand, and climate change. Here's a slide showing what we're currently doing in Southern California and many other parts of the country. But the first and most wide sweeping and most, I'd like to use the word powerful approach to saving water is house-to-house conservation, installing low-flow faucets, toilets, having a different ideology towards our plants and our landscape, maybe remembering that there hasn't been Kentucky bluegrass all over California for hundreds of years, so we probably shouldn't try to install it now with water in mind. Another that you've probably heard a little bit about is desalinization. That's using ocean water. It's a great idea. It's a great big source. It's also very, very hard to do and very costly. That water is salty, incredibly salty, and the equipment, it takes a beating. Groundwater development. It's not so common in San Diego. We don't have great sources of groundwater, but it is something to account for a small percentage. It's where you'll see groundwater used in this area is the wineries up north and a few dairies. They can use it for their purposes. But up north, the Central Valley or Texas, they wouldn't be able to use groundwater. Purple pipe, what you see here, recycled water. This is used, this is gray water, lightly treated water that is reused for irrigation and industrial purposes, but would never make it to our faucets. It's not that safe yet. And then today, what we're talking about is the Pure Water program. This is the most innovative of these 5 categories. This is the most innovative. This is what we're going to talk about a little bit more. And this is the idea of closing the cycle and reusing water that we've used directly into the system. Uh-oh. Sorry, it's a little, okay. So pure water. This slide's dedicated to pure water. This is the big picture of what we're trying to do. What we're going to do with this pure water system, which is it's a branch being run by the City of San Diego. It's part of the Public Utilities Department, and it's a new delivery method and treatment method for water. What this will do is provide half of the city's water supply. It's going to produce safe, high-quality drinking water, just like you would get from a bottle, provide a reliable, sustainable water supply where we don't need to depend on other states to provide water, or those 2 water sources that you saw in the first slide. And most importantly, offer a cost-effective investment for San Diego's water, whether it be potable use, industrial, agricultural. It's going to be a cost-effective method. We can't keep relying on those upstream retailers you saw how much the water increased over the past 20 years. It's not sustainable. This slide's a little technical, but again, questions are welcome at the end. Please ask to hold the questions. This is the existing system. This is how we and most places in the United States and around the world handle water and distribute water. It enters, you see the lower area, you see the reservoir. And then you see water sources, local runoff. That's the 2 sources. That's where the rain is coming, where the river is coming, and that's where we store it. We store it in those big reservoirs that you've probably heard around the news lately, Lake Murray and San Vicente, El Capitan. These are where we save big quantities of water. We send it to the drinking water plant, treat it, and then it comes to us here at the faucets, our toilets. Once treated, we send it just to the ocean. It just goes to we just send it right to the ocean. It's treated to a safe level, and send it back out, and we don't get it back, we don't benefit from it, and that's it. Also, one thing that I mentioned the last is the purple. That's the water reclamation. So we're doing a little bit of recycling currently. But what pure water is going to do is close the system. So instead of taking more water sources that bottom and sending more out to Point Loma in the ocean, we're going to basically cut off those two a little bit and keep it running inside. Keep basically a closed cycle, if that makes sense. So we're going to, instead of drain to the ocean, we're going to use it again. After treating it to incredibly healthy levels. That's the pure water facility, and we're going to talk a little bit more about that now. As I mentioned in one of the previous slides, San Diego Pure Water will produce half of the local water supply. Right now, we're finishing up, well, we still have a year or two, but as far as it's come, we consider it finishing up phase 1. You can see right there, this shows phase 1. Roy's going to talk a little bit more about these locations, but you can see we take water from Morena Pump Station, send it up to North City Water Reclamation and Pure Water Facility, and then it goes to Miramar Reservoir. So in this case, if you remember the past slide, where we had the reservoir, where it starts, so this is actually where, if you can think about it, we're starting back again. Phase 1 is going to produce 30 million gallons per day. I know it doesn't mean so much, that number, but that's a big number. It's a lot of water. and phase 2, which we're planning now, is going to produce about 53 million gallons per day. It's going to be located in a different area. Phase 1 was north, near the university. The second phase is going to be in the central area. We're looking into where we're going to plan this now, or where we're going to construct now. That's why it shows two arrows. Lake Murray and San Vicente are the two candidates, but there's lots and lots and lots of planning, lots of stakeholders. It's not a small decision. Here's a slide. This is showing our demonstration facility up at North City, up at Eastgate Mall. At this facility, they've had over 50,000 lab tests. Just to show, because we understand this concept of reusing water is not always welcome. It's a tough concept for people. So that's why this level of testing is done. We are required by the state and other regulators to constantly show that this water is essentially above and beyond what we normally have. And now I'm going to show a presentation, a video of the demonstration facility. Instead of going there, we like to show this video. I think it's about 10 minutes. And it's also available on YouTube if anyone wants to send this out to friends or family.
Welcome to the City of San Diego's Pure Water Demonstration Facility. This facility is a key element of the San Diego Pure Water Program, which will provide half of the city's water supply by 2035. The Pure Water Demonstration Facility uses advanced technology to treat recycled water to meet drinking water standards. This facility, here since 2011, has produced over 1 million gallons per day of purified water that is used for monitoring and testing. The results of this testing, combined with input from scientists, health experts, and outside laboratories, has shown that it is a safe new water supply for the City of San Diego. We're pleased to have you join our engineers, operators, and other staff associated with the Pure Water Program on your virtual tour of these facilities today. Phase 1 of the Pure Water program, which includes full-size treatment facility, pipelines, and pump stations, has been designed and construction is well underway.
The first step of San Diego's water purification process is called ozonation. Ozone gas is a powerful oxidant and is generated here on site by subjecting oxygen molecules to a high electrical voltage, converting O2 to O3. That's done by specialized equipment that's inside of the white metal container back there. That gas is then infused in the water and then it carries through a series of blue pipes called the ozone contactors. The contactors then provide time in which ozone can then react with constituents in the water. Ozone is very reactive and it'll break down pathogens that cause us harm by destroying their outer cell walls. It can also break down other smaller molecules to more basic forms. It takes about 8 minutes for the water to pass through this process. The second step is the biological activated carbon filters. By the time the water reaches the filters here, all the ozone in it will have either been consumed or it'll break down to O2, its more stable form. Inside of the filters is a media just teeming with beneficial bacteria. These bacteria consumes the organics that were broken down by the ozone process. We get about 30 to 50% removal of organic matter from this process. The beneficial bacteria are then removed to the next step along with any other thing that gets through the filter.
And here we are at the third barrier of the water purification process. It's called membrane filtration. At this stage, recycled water is pushed by high pressure pumps through filtration membranes that's made up of thousands of hollow fibers. These fibers have very fine pores that filter out particles, bacteria, and protozoa in the water. 99.9% of the particles cannot pass through this process. We're testing two types of membranes. On the left is the ultrafiltration. On the right is the microfiltration. The difference between these two types of membrane is that ultrafiltration take out additional organic matter, but it also operates at high pressure and requires more energy to do so. 1 million gallons per day of water passes through these two equipments. 500,000 goes to the ultrafiltration and the other half goes to the microfiltrations. All membranes are tested and monitored daily to confirm the integrity of the membrane filters. It only takes 1 minute for water to pass through these membranes. To prevent particle buildup on the membrane fibers, a process called backwashing occurs every 30 minutes. Backwashing reverses the flows of water and uses air souring to shake off any particle buildup on the membrane fibers. As the water gets processed through the membrane filtrations, it comes together here at this 15,000 gallon storage tank where it is ready to get processed and move on to the next barrier that's called the reverse osmosis.
Okay, now for reverse osmosis. So reverse osmosis is an extremely powerful treatment technology. It's able to remove 99.9% of what remains in the water after it's already gone through the 3 steps you've already seen. And we are actually testing 2 types, 2 configurations, and 2 manufacturers. The reason we did this is we wanted to be able to compare the performance of the membranes, how much removal we're able to get, and also be able to measure the energy consumption since this is an intensive treatment step. So similar to the membrane filters and the other processes you've already seen, we're constantly monitoring the water as it enters the RO membranes and exits. We want to make sure that we're getting the removal of the dissolved salts and the dissolved organic compounds that we expect. And so the way we do that, our operators pull samples from pores like these throughout the day. Each one of these is plumbed to an individual canister of membranes. So we take the water and we test it for temperature, electric conductivity, and other parameters just to make sure that the membranes are working properly. So if you follow me around the corner, we'll show you what they look like. So the membranes are actually these plastic sheets, and they're rolled in consecutive layers similar to a roll of paper towels. So you have the membrane, and in between you have this netting. It acts as a spacer. And so how it works is it's tightly wound. The water is forced under pressure on the outside of the canister, and it makes its way through each layer of the membrane. And what happens is those dissolved salts and organic compounds that we want to remove from the water, they get trapped in between the sheets, and they're forced out the ends of the canister. They're not allowed to continue on in the process, and so all that makes it through is the filtered water that gets to the center of the membrane, and this is what goes on to the next step in the process. And there you have it. That's reverse osmosis.
We are now at the fifth and final barrier of Pure Water Demonstration Facility, Advanced Oxidation with Ultraviolet Light. When the water leaves the reverse osmosis units, a powerful disinfectant is injected into it. This unit right here produces ultraviolet light, which is similar to extremely concentrated sunlight. There's actually 72 bulbs just like this wound up inside of the unit. When that ultraviolet light hits that disinfectant, powerful reactive molecules are formed, which actually destroy any matter that happens to be left in the water at that point. It's so powerful and so fast that in just 1 second, 99.9999% of all protozoa, bacteria, and viruses are all destroyed. This process also helps to ensure that no new matter is formed in the water going forward. And after this step is finished, we have purified water.
Now that the water has gone through the 5 treatment steps that you've seen, the water is pure and distilled water quality. The water produced at this 1 million gallon per day demonstration facility is tested to ensure that it meets all drinking water standards. As you can see, the water is pure, just as pure as the water that comes from the tap in your home. In fact, it's so pure that we'll have to add minerals back into the water before we pipe it to Miramar Reservoir. The water produced here at the demonstration facility is being returned to the recycled water system for irrigation and industrial uses. Phase 1 of the Pure Water program will construct a 30 million gallon per day full-scale facility that's 30 times larger that will use the same technology that you saw here in the demonstration facility. I hope you enjoyed this look at the City of San Diego's Pure Water Demonstration Facility. We invite you to visit purewatersd.org to get more information about this important project for San Diego's future.
Okay, so the reason why we have a virtual tour is the demonstration facility is located at the existing North City Water Reclamation Plant, which is currently under construction, so it's no longer available for public tours. I'm not sure if it will be open again after construction is over, but we will have a second demonstration facility as well, which I'll talk about later. Okay, so I'm going to give you all an overview of the Phase 1 projects and also sort of a status update of where they currently stand in construction. Mike introduced these projects previously. I'll give a little bit more of an in-depth look of what the Phase 1 projects look like. So at the bottom of the screen, we have Marina Pump Station, which is actually not far from here. This is a wastewater pump station that when it's constructed, it will pump an additional flow of wastewater from the sewer shed that's within this area of San Diego, and it's going to pump it up through Claremont and University City up to the existing North City Water Reclamation Plant. The North City Water Reclamation Plant, as originally designed, was a recycled water treatment plant. This was the purple pipe water that Mike mentioned earlier. This is water that's not suitable for drinking purposes, but used for irrigation and industrial uses. As part of the Pure Water program, we are expanding that treatment plant. We're providing additional treatment capacity so that the treated water from the North City Water Reclamation Plant can be fed into the new Pure Water facility to produce purified water. So after the wastewater is treated at the North City Water Reclamation Plant, it's pumped across the street at Eastgate Mall to the North City Pure Water facility. There it undergoes the treatment processes that were just described in that demonstration facility video tour. After it's been treated at North City, the water is purified. As mentioned, there's nothing in that water at that point. It is, in terms of water quality, a higher water quality than any of our raw water sources that we would import and receive. So from there, the purified water is pumped through the North City Pure Water Pipeline, which goes along Miramar Road into the Scripps Branch area, and it's discharged into Miramar Reservoir through a subaqueous pipeline. From there, it's blended with the existing raw water that's stored at Miramar Reservoir, and it's treated again at Miramar Water Treatment Plant before it goes into the distribution system and feeds the taps of the North City of San Diego. I'm not going to get into too much detail about the timeline here. This is an overview of the 12 major projects that are under construction as part of Pure Water Phase 1. A number of these projects started construction as early as 2019 and 2020. And as you can see from the estimated completion date, most of them are set to be completed later this year, with some other major projects that are set to be finished in construction next year. So as far as Phase 1 goes, we were pretty far along in construction. We can see the light at the end of the tunnel now. We're almost complete. And just to give you guys an idea of scale of these projects, we have some construction projects that are as small as $1 million for construction and some as large as $350 million in construction. In total, the Phase 1 program estimated cost is about $1.5 billion to design and construct and to deliver. And now we have one more video for the construction update.
After years of planning and engineering, Pure Water San Diego is becoming a reality. Pure Water San Diego is the City of San Diego's phased multi-year program that will provide nearly half of San Diego's water supply locally by the end of 2035. Pure Water San Diego is the city's largest infrastructure project to date, and we're making tremendous progress on the construction of Phase 1, which will deliver 30 million gallons of water a day. The program offers a cost-effective investment for San Diego's water needs and will provide reliable, sustainable water supply for generations to come.
Pure Water Phase 1 includes 10 major interconnected projects in the Marina, Bay Park, Claremont, University City, Miramar, and Scripps Branch communities, and construction's underway or completed on all the projects. To fund Phase 1, the city has been diligent and tireless in pursuing and securing as much federal and state funding as possible. To date, the city has received more than $1.4 billion in low-interest loans and $81.5 million in grants. Here's an overview of the Phase 1 projects. Starting from the southern end, the Marina Pump Station will divert an average of 32 million gallons per day of wastewater from the existing system that runs under Friars Road. In addition to the pump station under construction at Sherman and Custer Streets, this project also includes diversion structure and a junction structure under Friars Road. Once wastewater is diverted from the Marina Pump Station, it will travel through a 10.5-mile wastewater pipeline through Bay Park, Claremont, and University City.
The facility projects will be connected by 2 pipelines under construction. One to carry wastewater to the North City Water Reclamation Plant, and the other to carry the byproduct, or the remaining product from the water, to the Point Loma Wastewater Treatment Plant. Projects of this scale involve technical construction and high-tech equipment that requires experienced operators. While most of the construction will include trenched installation, tunneling with specialized machines will be completed in 3 areas, including under Interstate 805 to connect the pipelines with the existing North City Water Reclamation Plant. The wastewater will be cleaned to recycled water standards at the North City Water Reclamation Plant on Eastgate Mall, which is currently being significantly expanded from 30 million gallons per day to 52 million gallons per day. The recycled water will then be transported across the street to the North City Pure Water Facility, where it will go through a rigorous 5-step purification process. Once the high-quality purified water leaves the Pure Water Facility, it travels to Miramar Road eastward through an 8-mile pipeline under Interstate 15 and into Scripps Ranch, where the purified water will pass through a dechlorination facility in preparation for storage in Miramar Reservoir. The purified water will enter the reservoir through a 1-mile branched underwater pipeline and mix with water in Miramar Reservoir. This pipeline will be submerged and installed by divers.
As with all our City of San Diego drinking water supplies, purified water in the Miramar Reservoir will be further treated at the nearby Miramar Water Treatment Plant before we deliver it to our customers in the northern part of the city. Now let's go check out the construction at the North City Pure Water Facility.
Welcome to the brain of the Pure Water Phase 1 project, the North City Pure Water Facility. This is the largest of all major Phase 1 projects with an estimated cost of $365 million. Behind me, the construction crews are making progress on concrete above-ground walls and other structural components of the purification process building and the structural steel framework of the operation and maintenance building. Nearby, construction is underway on pump station and 4 pipelines that will connect the North City Water Reclamation Plant with the Pure Water Facility. Construction started April 2021, and most of the foundation and underground work, like piping and duct banks, is already complete. In addition to the water purification process buildings, this facility will also feature a new LEED Silver certified 33,000 square foot operations and maintenance building with workspace and a discovery center for the community to learn more about Pure Water San Diego and a sustainable water future. Let's look at construction from above on the 5-step purification process. Here's the ozone building. Right now, crews are working on structural components like the upper level walls, mechanical components like plumbing, and electrical conduit installation. Underneath, the water goes through the ozone contactor. As you can see, the walls are complete and crews are working on the lighting conduits. The water then passes through the biological activated carbon filters, or BAC. Here at the BAC system area, crews are working on stairs, walls, and roof deck rebar installation. Next, the water goes to the membrane filtration feed tank, where crews are working on the tank structure and decking. Here you can see the multi-level process building that will eventually house the membrane filtration and reverse osmosis equipment. Crews are working on pipe installation throughout the basement level and walls on the ground level. This is also where the water will undergo UV light and advanced oxidation, the last step in the purification process. As you can see, North City Pure Water Facility includes many different areas under construction simultaneously, all tightly orchestrated on this 10.5-acre site. The crews are what makes it happen here. Creating local jobs and putting San Diegans to work is a vital part of Pure Water San Diego. As of March 2023, program-wide, there are an estimated to be 2,022 people working on all the projects. 1,330 of these are Pure Water San Diego construction workers that live in San Diego County and 466 people that live within the city of San Diego. On this construction site alone, there are between 75 and 120 craft trade personnel working daily. We look forward to completing the Pure Water San Diego Phase 1 projects and making pure water a reality for generations of San Diegans through a local, drought-resilient water supply.
All right. I have some additional construction photos to show you all. This photo behind me is some of the open trench construction work that's being done as part of the Marina Conveyance South and Middle project. So this is the wastewater pipeline that's going to convey wastewater from Marina Pump Station up to the North City Water Reclamation Plant. This is some of the trenching work that the contractor was doing. You can see the footprint and sort of scale of construction. If you have been impacted by some of the traffic lane closures during construction, this is sort of the reason why. The equipment is very large, the trenching is deep and wide as well, and it's a large operation. This is an aerial photo of some of the work that's been happening at the existing North City Water Reclamation Plant. So as I mentioned earlier, this plant is being expanded to handle increased treatment flow. So what we have here are 2 additional secondary clarifiers that are being constructed. Secondary clarifiers remove floating scum and other particulates within the wastewater. So the 2 that are shown here that are full, those are existing. The 2 empty ones are the new ones that are being constructed. Here we have a photo of the construction of an additional flow equalization basin at the North City Water Reclamation Plant. Flow equalization basin, it helps to regulate the flow going into the treatment plant. Ideally, we'd like to have a continuous, steady flow rate. So during high flow periods, the equalization basin will fill up and store the wastewater. During low flow periods, it'll drain out and equalize and add additional flow to the treatment plant. And this is necessary to help make sure that the treatment processes at the treatment plant are functioning as they're supposed to. Here we have a photo of the Metropolitan Biosolids Center. I didn't actually mention this one earlier when giving an overview of the Phase 1 projects because it's sort of an ancillary piece, but the Metropolitan Biosolids Center is an important part of our wastewater treatment system. What it does is it treats the biosolids, so the solid residuals that come out of our wastewater treatment plants, and it treats them there, it dewaters them, and so as part of Pure Water Phase 1, because we're increasing treatment capacity at North City, we're adding a treatment plant for the North City Pure Water facility. We're also going to increase biosolids flow to the Biosolids Center. And so therefore, as part of the program, we're doing some upgrades there as well. In this photo, you can see some of the dewatering centrifuges that are being constructed at the Metropolitan Biosolids Center. And here's the Pure Water facility. You all saw that video just previously showing a lot of the construction progress. This is a more recent aerial photo, the one on the right. This is, starting at the front is the very, very large operations and maintenance building and Discovery Center, which after construction is completed, the Discovery Center will be open to the public. There will be educational components there and other exhibits that would be helpful for the public to learn more about the facility. And here is the Pure Water pipeline. This is the pipeline component at Miramar Reservoir. So as mentioned previously, purified water is delivered to Miramar Reservoir and then distributed into the reservoir through an underwater pipeline. So what you see here in the photo is the construction of the underwater pipeline. It starts as a 54-inch HDPE pipe, and it narrows down into smaller diameters depending on the segment of the pipeline. And so the photo on the left shows the contractor pulling the HDPE pipe to float out onto the reservoir. All of those gray squares that you see on there, those are concrete weights that are attached to the pipeline so that the pipeline will stay submerged at the bottom of the reservoir. Because the pipeline is empty as they pull it out, it floats. But what they do is, as they pull it out onto the reservoir, they slowly fill it with water, and then it sinks. And it's called an S-bend because it sinks from one end, it forms an S shape, and it slowly just sinks down to the bottom. This pipeline has already been constructed. It's already at the bottom of Miramar Reservoir. This portion of construction is already complete. Here we have the Miramar Reservoir Pump Station Improvements Project. If you have ever been to Miramar Reservoir, as you're walking around the loop of the reservoir, if you look down to the south past the dam, you can actually see these pumps there. These are the intake pumps for the treatment plant. These pumps pull water from Miramar Reservoir and pump it into Miramar Water Treatment Plant so that it has enough pressure to flow through the treatment plant for treatment. And because we are putting 30 million gallons per day of purified water into Miramar Reservoir, these pumps are going to have to operate more or less continuously. So as part of our program, we're constructing some upgrades to this existing pump station. We're rehabilitating some of the existing pumps. We're adding variable frequency drives to allow operations to better control the flow going into the treatment plant, and also some other electrical upgrades as well. And Mike mentioned earlier, we're currently in the process of planning for phase 2. So Mike and I we are working on phase 2 planning components currently. We are looking at different options of where to place the phase 2 facilities. We know that it's going to be in the central area, but as far as where the treatment plant will be sited specifically, where the purified water will be conveyed to, whether it's Lake Murray or San Vicente Reservoir or a combination of two, that hasn't yet been determined. We are looking at studies that involve water balance between the reservoirs. We're looking at water quality. We're looking at ease of operation. So there's a lot of components that we're currently looking at before we come to a decision. And we have here a phase 2 small scale facility. So this is sort of the equivalent of the demonstration facility that's currently at the North City Water Reclamation Plant, which we had a virtual tour for. As mentioned earlier, as part of the program, we have to demonstrate to state and other regulators that our treatment processes work, that we're removing the contaminants that we say we will. That has been done for phase 1 already, but for phase 2, we're doing the same thing because our wastewater characteristics are a little bit different. We are testing new treatment technologies, and so this small-scale facility is really important for us to test them, to run thousands of lab results, and to demonstrate to the regulators that what we're planning to do for phase 2 is going to work as expected. So this one is going to be located at Point Loma Wastewater Treatment Plant. It is currently under construction. This is a project that Mike used to work on.
It was fun. It was really fun. It's a beautiful location.
It is. And sustainability is key for this program. The aim of this program is to provide the city with a safe, local, reliable, and sustainable water supply. I think that's sort of been the theme throughout this whole presentation. And Pure Water receives broad support within the community. Here are just some examples of businesses and organizations that support Pure Water. And the Pure Water program has come a long way. It started from the early 2000s to having a sort of a negative reaction from the community and public to now having very broad support for what we're trying to do for the region. And if you'd like to learn more, we have some links here that you can check out for additional information and updates. And with that, I'll go ahead and open up to any questions.
Okay. Well, I want to know, how many stages are there?
Of the program?
Yeah.
By official documents, there can be potentially up to 3 phases. So the city's sort of service areas are broken up into three. There's the North City, the Central area, and then the South area. So as phase 2, we're looking at the Central area. Phase 1 is doing the North, and potentially, if needed, phase 3 in the South. We're currently not doing anything with regards to phase 3, but there's a potential for it if needed down the road.
Okay. Is this pure water project what has been called toilet to tap?
That was
And
the
I-
negative reaction that
and I can see you
that
cringe
referred
as I
to.
said
Yeah,
that.
yeah, and it's a mischaracterization, definitely. But yeah, previously the public perceived it as such.
Okay. Let's see. So biosolids are dewatered? Do they turn into dry solids?
They
And
do.
where-
They do.
And where do the dry solids go?
Typically landfill.
Landfill, okay, oh, thank you. Are there safety protocols specific for weather/earthquakes, and how far south does this affect water? Any safety protocols for?
Well, all of the pipeline, and, sorry, the pipeline that we have, the treatment facilities and all those big, concrete structures you saw, we design those and build those to a different level, with a different level of safety, much deeper foundations, much bigger rebar than you would see at a normal, a normal office building, or, those are built to take on
So that
pretty
would,
strong.
it would have to be a big earthquake to,
Bigger than anything we've ever seen here.
okay.
Yeah.
Good.
And when the second part of your question about how far south,
Yeah.
Oh, yeah.
is that whoever wrote that question, is that a question of where the water goes and where it's distributed within the
Just says,
city?
how far south does this affect water? I'm not sure, who?
Oh, to the board. No. Purified water is not designed to be going down to Tijuana. It's for the service areas within the city of San Diego.
Okay.
Just San Diego. Just to San Diego.
Please repeat the percentage of San Diego water that Phase 1 will provide, and what is the anticipated percentage when you finish the whole thing?
Okay. Yeah, so when phase 2 is complete, 50% of the city's supply will be provided by Pure Water San Diego.
Okay.
So at the end of phase 2, that'll be 83 million gallons per day. Phase 1 is 30 million gallons per day of that.
So is this going to decrease the amount of water that we need to import from? Yeah, okay, good.
Yep.
Good.
That's the goal. That's the big picture.
Okay.
One of the goals.
And Mike had talked about previously the price increases for imported water. I've actually seen the price projections from Metropolitan Water District, which is the largest water wholesaler in Southern California. I've seen what those price increases look like for the next 10 to 20 years, and it's only projected to continue to grow higher.
Oh, yeah. Well, there's like 5.5% they're adding soon in the next couple of months, yeah.
And they know there's nothing else we can do, so.
Okay. Will Lake Hodges ROS reopen or contribute to this at all? Reservoir. Is Lake Hodges involved at all?
Lake Hodges is not a part of the Pure Water program. I know that there's construction ongoing for the Lake Hodges Dam, but that's a separate project that's not related to the Pure Water program.
Now, they mentioned two different filtration systems in the video, but they never said which one was better. They said that the one requires lots of energy, but.
None is necessarily better than the other. Different treatment processes target different removals, but they also have overlap. So they're redundant in ways that they remove similar things, but different treatment processes are for different purposes. So it's not necessarily that one is better than the other.
Okay, so how much energy does this whole thing take?
That's a good question. That's a good question. That's actually something we're looking into now. It's an entire study that we're working with one of our consultants now, an electrical engineering expert consultant, to figure that out, because that is a big question, and it's very hard to put a number on it. But it's something that we're looking into now.
And where is that energy coming from? And will that...
Well, San Diego Gas and Electric would be, they're involved heavily.
And just to add to that, I mean, drinking water and wastewater treatment requires energy. And just to compare to the other alternatives that we do have, desalination was mentioned earlier. Desalination requires even more energy. And also, as far as where our existing water comes from, Mike mentioned it earlier in our slides. Right now, 85% of our water is imported. That water doesn't just flow by gravity to us. The State Water Project and water that we receive from the Colorado River is pumped over hills to our region across miles of pipeline. That also requires an enormous amount of energy as well. And those large conveyance pipelines also cross fault lines. They are also subject to earthquake risks as well. So, you know, the energy requirements for treating and recycling water here is high, but it's important to consider that our other water sources also require a lot of energy as well.
Okay, I was taken by the fact that you take this water, you make it so pure, so clean, and then you put it in a lake.
You know, it's a new concept, this what we're doing. So for now, you know, dealing with the public and the regulators, we need to go a little bit above and beyond until you know, probably for decades, until people think of it differently and have a more because currently right now, yeah, we're against the wall, and so we need to really prove it's great.
Putting the purified water in a reservoir, you know, Mike is...
Where water is not pure.
Correct. And Mike is correct. We don't really have a choice. Regulators require it. But it does serve a specific function because the reservoir is an environmental barrier. Because if something fails within our treatment process and the purified water doesn't meet the water quality that we expect it to, it's still diluted and blended within the reservoir. There is still a barrier there where if our water quality is not as high as it's supposed to be, it's not going to go directly into the drinking water treatment plant. But again, the drinking water treatment plant is another barrier as well. Purified water is treated, it's blended, and it's treated again.
Okay. Why can't we use groundwater?
We could if it's just not sufficient in San Diego. There's very few, you know, places up north in the Central Valley or parts of Texas, Oklahoma, like the Ogallala Aquifer. It's the size of half of Texas. You know, we have in Southern California very, very small aquifers that are not really, you know, they're good for the citrus farms, maybe a small citrus farm, a dairy farm, but not. We couldn't rely on it.
In San Diego, at least, a lot of our groundwater basins are brackish, meaning that they have high salinity due to the proximity to the ocean. I think geologically, we don't have the groundwater structures underground to support large storage. But you know, regions such as Orange County and Los Angeles do have large groundwater basins, and they utilize their groundwater. It's just geologically, here in San Diego, we don't really have that available. At least it's a limited capacity, and what is available, a lot of it is brackish, which would require a fairly high level of treatment as well.
How does this system interact with systems that serve North County?
A follow-up question. You're talking about during the high rain event when we had flooding, right? This is something that is discussed a fair bit within the city. Stormwater, that would be the term for it, when we have a very large rain event and it's flooding in the street. Stormwater is difficult to capture and treat for a couple reasons. The water quality in the stormwater is different than the water quality that we would expect from either water that we pump out of the ground or even wastewater that we're going to treat to recycle. Stormwater picks up heavy metals off of the streets that come out of car brakes. It picks up all sorts of different contaminants from the surface that we wouldn't typically see elsewhere, and that characteristic of water quality is not what our treatment plants are designed for. It would potentially disrupt our existing treatment plants. And then secondly, the volume of water that would come during a storm event such as that requires really significant infrastructure to construct, to capture and treat. And that type of source isn't very reliable. It comes when we have large rain events, but we also go through significant months of drought or years of drought where we receive nothing. So the capital investment required to capture and treat that flow of water during a rain event like that is kind of hard to justify compared to something such as the Pure Water program, where we know wastewater flows are constant because homes and businesses are constantly using water and producing wastewater.
You know, that's a good, on that question though, out east in the Midwest, first of all, where the systems are older and they built things just at one time, they didn't have the, they just built one pipeline, so it was just all the home sewers and the stormwater. They call it a combined system. They do that, what you're talking about, but it is a different, it did require different technology, a different starting point. And also the out east, it's very consistent, the storms, so you can rely on them. Lakes all over, the Great Lakes, where here, like Roy said, it's just not as reliable. So we wouldn't want to rely on that as a public.
Yeah, I don't think you guys have properly identified in that community because we had a truck on Lincoln's Field sinking before the floods. That's when we knew we had a problem, and that's why the field, you all heard about the football field that we didn't do. It's because we literally had a truck on the field and it was sinking and we couldn't figure out where the water was coming from. It wasn't coming from our pipes. This is before the flood, so when the flood happened, it just compounded the problem. And we did bring OTI, some consultant in from OTI to talk to us about whether or not we wanted to put a pumping station right there at Lincoln and Porter schools in order to at least water the lawns over there. So we couldn't figure out what was going on. We had that problem, I guess, up at Kearney High School area. There's been several pockets around that we have not identified. But I'll talk to you guys.
Yeah, please, that will help
Okay.
there.
What is the long-range life of the microfiber filters?
Oh, God. Who asked that? All right, yeah.
Do we know?
At this moment, I can't give a number of years, but these types of treatment equipment, so reverse osmosis, filters, membrane filtration, ultrafiltration, they have to be replaced over a certain time period. I'm just not sure what that time period is.
Okay, in its early days, what are the possible funding cuts of the current federal government capable of doing to pure water?
I wouldn't want to expound too much on that, but at this.
Do you depend on federal monies?
We do. A portion of the program is funded by Bureau of Reclamation grants. We also have WIFIA loans as well. So we rely on a portion. I think there was actually a dollar amount listed in one of the videos. Mm-hmm. We do rely on federal grants and loans for this program, but not entirely.
Okay. And the 1.4 billion funding is city bonds or not?
A combination of many sources.
State funding, federal, and then, yeah, of course, the ratepayers.
Okay. What is the projected savings comparing current water from Colorado and Sacramento to pure water? The savings comparing importing the water to fixing it ourselves.
We don't know yet. We don't know yet. It's gonna be something we're finding out as we implement the program.
And the reason why we don't have an exact pinpoint on what that is because the cost of imported water is projected to change. So it's increasing year over year. And we are soon going to hit the point where the cost of producing local purified water through through the Pure Water program is going to be lower in cost compared to importing water. But that imported water cost is changing over time.
Okay, a couple of people have questions that indicate they've heard some stuff. It's, will the ultraviolet disinfectant cause cancer?
No.
Of course not. It's
Yeah,
sunlight, right. I just wanted to answer that. I heard that water from your water faucet is safe to drink if you put in glass container. Let sit for 24 hours so chlorine can evaporate, then drink. Is this true? No.
It is safe to drink the water directly from the tap.
Yes. Just wanted to clear those up. How does this system interact with systems that serve North County cities? Are there shared resources or separate systems?
So the city of San Diego will sell treated water to some cities within North County. The city of Del Mar is a customer, but I think some of the cities north, Encinitas, Carlsbad, I think they have their own sources that they purchase from the county water authority.
Okay. Do you foresee Mexico ever controlling the Tijuana River sewage problem?
That is outside the
Outside
scope of
your
our
purview.
program. We're limited to the city of San Diego.
Phone a friend on that.
With all the high-rise apartments being built throughout San Diego, is this available amount of water capable to handle the additional home water requirements?
Yeah, the intent is to have a surplus.
Oh, nice.
Yeah.
And the increased density of development where we have high-rise apartments rather than single-family homes that have potential front and backyard landscaping needs, the water demand is different. So typically denser development is actually a little bit easier as far as water demand goes.
Oh, okay. Okay, I think we covered everything.
You can try the other ones, and we might defer them if there were, but I don't want to shut it down. But I can imagine people are probably want to stretch and.
Yeah.
Hi, I was wondering, I've been a resident of San Diego about 32 years now. I would say about 25 years ago, they were talking about how the risk to the water supply in San Diego would have been, from an earthquake, would have been like a break in a pipeline or something that was feeding the county. Is that part of the incentive for building this pure water program, was to make San Diego self-sustaining?
Absolutely.
In its ability to,
100%.
Yeah.
Because there are risks to the aqueducts and the large diameter pipelines that are coming and bringing imported water into the region.
Right.
And they are subject to earthquake risks. Obviously, that infrastructure is also designed to be resilient, but there's a certain magnitude of earthquake where, if it happens, there is a high enough risk that we could potentially lose that imported water source. And so one of the major drivers of the Pure Water program is to have a local source that's independent of whatever is happening outside of the region.
Makes me think of the Roman aqueducts that are still standing.
Yeah. No, I'm just thinking of the movie Earthquake now. Right? Earthquake, Charlton Heston. But on that question, that kind of ties to the cost thing too is we want control. It's not necessarily going to be so much cheaper today, but we have the control. You know, we're not at the mercy of people in other states and
Yeah, the trade-off, right? It's absolutely, it's an investment in the trade-off of having to source something from outside of our area and being in full control over.
Yeah, exactly. It's an investment in ourselves.
Right.
You know, and like they mentioned, there's a lot of people that are employed. You know, it's good for the economy. It's not just the water, but it's good for the city.
Right. I actually was the person who asked the question about the other water systems around the county, and it's interesting to me that this system is designed to feed such a smaller section of the greater San Diego County. How do the other areas of the county get served, and does that put any burden on San Diego City's system?
Isn't that phase 2 and 3?
A portion of it. It's a little bit complicated because the city of San Diego has member agencies within what's called the Metropolitan Joint Powers Authority, in that the city of San Diego receives wastewater flow from other jurisdictions outside of the city. And we have agreements with them. We receive their wastewater. We treat it at our wastewater treatment plants. And as part of the Pure Water program, we will take that wastewater and we will produce recycled water for drinking water purposes with it. As far as drinking water supply, other jurisdictions have their own means of doing so, whether that is purchasing water from the county water authority, or doing their own version of the Pure Water program. So for those who may be familiar with portions of East County, Padre Dam Municipal Water District is one of the larger municipalities there. The East County JPA that was formed with the County of San Diego Helix Water District and others, they are implementing a similar program for recycled water there. I believe the city of Oceanside has a much smaller scale version of this program as well. So other jurisdictions are doing similar things, but the city of San Diego, you know, we're really focused on the service areas within the city, and other jurisdictions, they have sort of their own strategies that are in some ways similar, in some ways a little bit different.
Makes sense. I guess as somebody who knows nothing about this, right, I'm a bit surprised that it isn't, that the greater region isn't served more universally from one system rather than being these disparate systems. So I live in San Marcos. I know that we're served by like the Velocitos Water District or something like that. And I know there's a giant supply line that runs literally through the community that I live in. That comes from like 100 miles north or something, like Riverside or something like that. So it's really interesting to me, and just.
It is interesting here. No, the system coming from another part of the country, with Sweetwater Authority and Helix and City of San Diego, and it's very interesting. Southern California is an interesting scene with the water distribution.
And as someone who lives in San Carlos, I'd like it to go to Lake Murray, please.
Yeah.
It is something that we are looking at right now as part of our studies. And you know, to your point, the city of San Diego does collaborate to a certain extent with all these other jurisdictions. It's just sometimes when it comes to the technicality of delivering water, there are usually other factors at play.
Stuff that's like politics. Stuff that's not fun. Yeah. Yeah.
Thank you very much.
Yeah.
Thank you so much, gentlemen. Did you have anything you wanted to add, Michael?
No, but I did want to get. I did want to get her answer for that pretty technical question about the life of the materials. I'll get an answer to you.
Okay. Thank you so much for joining us here today, Michael, for you.
Oh, thank you. Thank you so much.
And Roy.
Oh, thank you.
And Marissa.
Thank you for having us all.
Please plan, if you can, join us for a brunch and talk with folks, maybe talk with Dr. Whitehurst Payne back there. She was the one who was asking those questions for you, okay? Anyway, please fill out your evaluations at your tables. Thank you for all the donations that you may have put in the hats. And now to close. This is from Micah 6, verse 8. He has told you, O mortal, what is good, and what does the Lord require of you, but do justice and to love kindness and to walk humbly with God. Those are powerful words. And thankfully, we have a lot of work going on the water to sustain us and for risk reduction in water supply. Thank you all very much. Let's have lunch.